Okay, so for our first day of Trig, we're going to start here with just the basics of how these ratios function. So if we have what we refer to as theta, if we have what is referred to as theta up in this corner, that's the angle that we want to focus on. And we're going to have two different types of sides. We're going to have sides that are opposite of theta and sides that are adjacent to theta. So if you think about the word adjacent, if you are in a room adjacent to someone else, you're in a room next to them. So this side here for AB would be our side that is adjacent, and BC would be our side that is opposite, and AC would still be our hypotenuse. So we're going to have three different sides that we're going to be thinking about here. Adjacent, opposite, and hypotenuse. Here, if our theta is down here in this bottom corner, then now my adjacent side is FE, my opposite side is DE, and my hypotenuse is still opposite my right angle for FD. So when we're setting up our sine, cosine, and tangent ratios, we are going to use the phrase SOHCAHTOA. So it is sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now, the way that I actually prefer to write these is as ratios. So if I think of SOHCAHTOA in my head, I do sine is the opposite over hypotenuse. Cosine is the adjacent over hypotenuse, and tangent is the opposite over adjacent. That way I can actually see and visualize those ratios. So here, when it asks us to find the tangent of A and the tangent of B, the type of answers that we are going to want are going to be simplified ratios. We're not actually looking for a side length because they're all there, and it's not asking us to find an angle. This is merely just setting things up. So if I look at angle A, and I focus solely on angle A, then I know that I have my adjacent, my opposite, and my hypotenuse. So if I want the tangent of A, I know that tangent is opposite over adjacent. So it is 45 to 28, and then we always want to make sure that that is simplified, and it is. Nothing else will move from there. So now, if I want the tangent of B, I'm focused up here. So now what I want to look at is, for my turquoise angle B, 28 is now my opposite, and 45 is now my adjacent. So if I want the tangent of B, my opposite is 28, and my adjacent is 45. Those are the types of answers that it wants us to have for these types of questions. So if I want the tangent of A here, let me switch back to the blue. Then I have my opposite, adjacent, and hypotenuse. So the tangent ratio for A will be opposite over adjacent, 56 over 33. And those won't simplify either. And now if I want to look at tangent of B, here is B. And I want to move over here. So now I have opposite and adjacent and hypotenuse. So my tangent of B would be the opposite 33 over the adjacent 56. So if we're looking for the sine of R, I'm going to use my pen here. So again, I have my adjacent, my opposite, and my hypotenuse for the sine of R. And if I want to work from there, I know that the sine, so, is opposite over adjacent, is opposite over hypotenuse. So 15, the sine of R, is 15 over 25, and that will simplify down if we divide them both by 5, so 3 to 5. And now if I want to look at the sine of S, I have S here, and I would have now opposite and adjacent and hypotenuse. So sine, S-O-H, so the opposite over the hypotenuse would be 20 to 25, which is then 4 to 5. In the same way, we can do the same with cosine. So cosine is ca, C-A-H. So the adjacent over the hypotenuse. If I want the cosine of A, here is my hypotenuse, my adjacent, and my opposite. So the cosine ratio for the angle A would be adjacent 48 over the hypotenuse 52, which should simplify down, I believe, to 12 to 13 if we divide them both by 4. And now if I look at the cosine B, here is angle B. So this is my hypotenuse, my opposite, and my adjacent. So for my cosine B, I am going to have the adjacent 20 over the hypotenuse 52. So if I divide those both by 4, I get 5 to 13. All right, so now we're actually going to apply these. And notice this note at the top of your calculator. It says, make sure that your calculator is in degree mode. If you have your graphing calculator, you will click the mode button, and a few rows down are the options for radian or degree. You want to make sure to arrow over to degree and hit enter. If you have one of the TI-84s, it should tell you up at the top. It'll say normal, float, auto, real, and then that next to last one will either say degree or radian. We always want to make sure that we are in degree mode. It doesn't really matter for anything except for trig at this point. So just as a general rule, make sure that you are in degree mode. All right, so I'm going to write my ratios up here at the top. So SOHCAHTOA, sine is the opposite over hypotenuse. Cosine is the adjacent over hypotenuse. And tangent is the opposite over adjacent TOA. All right, so if we want to find A, notice that we've got our 57-degree angle that's given. And in reference to that 57-degree angle, I now have my adjacent, my opposite, and my hypotenuse. So if I'm looking at 57 and I want to find A, I notice that I need the adjacent and I have the opposite. So if I need the adjacent and I have the opposite and I look up at my ratios, I notice that tangent has both of those sides in its ratio. So what we're going to do is we're going to rewrite, and instead of putting the tangent of A as in an angle, we're going to put that degree in place of that letter. So the tangent of 57 is equal to TOA, the opposite angle, the opposite side, 14 over the adjacent side, A. So here's where we're going to take a look at how ratios function. If I want to solve this ratio for A, then what I'm going to do is I'm going to multiply both sides by A, and I'm going to divide by the tangent of 57. In the same way, if I had 5 equals 10 over x, right? I'd multiply both sides by x, and I'd get 5x is equal to 10, and then I'd divide by 5. So in the same way that we would rearrange this ratio up here on the top left, we're going to rearrange this one on the right just to kind of show you the feel for it. And then after that, you can just kind of cut straight to it. So to get rid of this a, we're going to multiply both sides by a, and we end up with a times the tangent of 57 is equal to 14. And then we are going to divide by this tangent of 57 on both sides. So this is what we're going to call our calculator ready setup. To put it into the calculator, we're going to do 14 divided by tangent 57. And when we plug that into our calculator, 14 divided by tangent 57, I end up with 9.09, and it does not tell me what to round to, but let's just get into the habit of rounding our sides to the nearest tenth. So this will be 9.1 units. Okay, so now let's go up here and let's find B. I'm still going to stick with my 57-degree angle, and in this case, I don't want to use the 9.1 since that value is rounded. Let's stick with the 14. So for B, I have the opposite, and I need the hypotenuse. So if we look up at our trig ratios, that is sine. So I'm going to use 57 and say the sine of my 57-degree angle is opposite over hypotenuse, so 14 over B. And we're going to do the same thing. Notice how it is set up the same exact way. So I'm going to take this, and instead of having to go through all this jazz over here, I'm just going to swap B and the sine of 57. So for calculator ready, my setup is going to be 14 divided by the sine of 57. And I end up with 16.7 units. Now, just to kind of check on this, doesn't it make sense that my hypotenuse is the longest side? So just kind of another little check there that we can make that work and put that 16.7 for our hypotenuse. All right, so let's do this one here. We have almost an isosceles triangle, but we got 47, so the other angle will be 43, so just a few degrees off, just to kind of keep that in mind so that your x and y are pretty close to each other. If I want to solve for x in reference to my 47-degree angle, here is my adjacent and my opposite and my hypotenuse. So if I want to solve for x, then I have the hypotenuse and I need the adjacent. So this was going to be cosine of my 47-degree angle is equal to, for cosine, it is adjacent over hypotenuse. So x over 12. Now notice the difference here in how these two look and where your variable is. So in this case, our 12 is in the denominator and our x is in the numerator. So that our calculator ready is going to look different. The way that we're going to get this calculator ready is to multiply both sides by 12. So my calculator ready is going to be 12 times the cosine of 47. Now you don't have to put that multiplication symbol in there. You can just plug in 12 cosine 47, and we end up with a side length of 8.2 units. So now let's go find y. I still want to use my 47-degree angle, and in this case I have the opposite and I know the hypotenuse. So this is my sine. So the sine of my 47-degree angle is equal to the opposite over the hypotenuse. The opposite in this case is y. The hypotenuse is 12. So to get it calculator ready, I'm going to multiply both sides by 12. 12 sine 47. 12 sine 47 in the calculator, and that gives me 8.77, so 8.8 units. And it is pretty close to an isosceles triangle. All right, so let's do one more and then we'll move on to the angles. If I want to find x here, according to my 50-degree angle, this is my adjacent and my opposite. So if I know the adjacent and the opposite, this is my tangent ratio, so TOA. So I'm going to do the tangent of my 50-degree angle is equal to the opposite 13 over the adjacent x, and I'm going to swap the x and the tangent of 50. So to get it calculator ready, I'm going to do 13 divided by the tangent of 50. In the calculator, 13 divided by tangent 50 says round to the nearest tenth, so 10.9 units. Okay, so let's look at solving for angles using our inverse. So remember that we still have sine, cosine, tangent. So sine, is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And in this case, whenever we set it up, we are going to use our, what do I want to say, trig ratio, but we're going to have like sine of our angle is equal to our ratio. Okay, so maybe x over y. In this case, if we want to solve for our angle, we're going to use what is called the inverse. So what we'll plug into the calculator would be the sine inverse of x over y. This will be to find our angles. All right, don't forget that you can always use Pythagorean theorem. So if I have 7 and 15 to find the value of m, I'm going to use Pythagorean theorem. 7 squared plus 15 squared is equal to c squared. And if I do 49 plus 225, that gets me 274. And if I do the square root of that, since it wants us to go ahead and run it to the nearest tenth, this is going to be 16.6 units. Okay, so now if I want to find angle M, if this is 16.6, that's great, but I don't want to use the 16.6 in my calculations unless I absolutely positively have to. And in this case, we don't have to because I have 15 and 7. So, if I take my angle M, and this is the angle that we are considering, then here is my adjacent and my opposite. So I'm going to use tangent, and I'm going to plug it in just like I did my original ratios. So the tangent of angle M is equal to the opposite 15 over the adjacent 7. And to get it calculator ready, what I'm going to plug in is the tangent inverse of 15 over 7. So second tangent, 15 divided by 7, and I end up with 64.98. So let's talk about this for just a minute. If I end up with 64.98, if we are rounding to the nearest tenth, there needs to be a tenth digit there. So the 8 will round up the 9, and 9 will round up the 4, and I end up with 65.0 degrees. Make sure that you put that 0.0 in there to signal that you rounded to the nearest tenth. All right, so now if I want to find angle N, I'm going to erase what I had previously done here. And now if I want to find angle N, I have got my adjacent with a 15 and my opposite with a 7. So this is again going to be tangent. And I'm going to do the tangent of N is equal to the opposite 7 over the adjacent 15. And to get it calculator ready, I'm going to do the tangent inverse of that ratio, 7 over 15. So second tangent, 7 divided by 15. And I end up with 25.016, so 25.0 degrees. Now, what you'll notice that even with these rounded to the nearest tenth, they should still all add up to be 180. All right. Solve the right triangle. That means find all the other missing pieces. So round your answers to the nearest tenth. I know the hypotenuse. We can subtract to find our angle. So if I do 90 minus 37, that will give us our 53 degrees up here. So angle P is equal to 53 degrees. And now we can either use the 53 or the 37 to find our other side lengths. I'm just going to go ahead and use the 37. So this is my hypotenuse, my opposite, and my adjacent. So to find QR, I need the adjacent and the hypotenuse, so that is my cosine. So the cosine of 37 is equal to the adjacent A over the hypotenuse 22. And to get this calculator ready, because the 22 is on the bottom, I'm going to multiply 22 cosine 37. And that will be equal to 17.6 units. And if I want to go ahead and find PQ, I have the opposite of the 37 degrees and the hypotenuse, so this will be sine. The sine of 37 is equal to my opposite side over my hypotenuse 22. So my calculator ready will be 22 sine of the 37 degree angle. So 22 sine 37 gives me a value of, let me get back to it, sorry about that, rounded to the nearest tenth, 13.2 units. Okay, now let's look at number 6 and go from there. So number 6, we don't have any angles, so we need to find those angles. And for number 6, it wants us to go ahead and round those angles to the nearest tenth, I believe. All right, so I have 19 and 28. Let's find angle E first. Not for any real reason, just because that's what I picked. So this is my adjacent and my hypotenuse. And for angle E, let's see. I have adjacent and hypotenuse, so that is cosine. The cosine of angle E will be equal to the adjacent 19 over the hypotenuse 28. So to get it calculator ready, I'm going to do the inverse. Cosine inverse of 19 over 28. Second cosine, 19 divided by 28. And I end up with the measure of angle E being approximately 47.3 degrees. And honestly, we can just go through and subtract that from 90 to get the measure of angle U. So if I do 90 minus 47.3, then I end up with 42.7 degrees for the measure of angle U. If you want to do trig with that, you are more than welcome to. If you want to use trig, just make sure that you move around your adjacent and your opposite. And in this case, you would use the sine of U is equal to the opposite 19 over the hypotenuse 28. So your calculator ready would be the sine inverse of 19 over 28, in which case you'd end up with the same answer. Now, as far as finding the length of UM, don't use one of those rounded angles. I mean, you can, but let's go ahead and just do Pythagorean theorem. So a squared plus 19 squared is equal to 28 squared. So in my calculator, if I do 28 squared minus 19 squared is 423, and take the square root of that, I end up with 20.6 units.